All right, topic 3 is going to be finding the area of a triangle using the law of sines. So if we think about the area of any triangle, the area of a triangle comes from the area of a rectangle, but we're just taking 1/2 of the base times the height. Well, this is all well and good if in an oblique triangle like this, we would say we want 1/2 the base times the height. And I would want to be able to figure out what in the world is this height. I know the base is 10.3, but I need to do some work to figure out what is h equal to. Okay, so you don't have this quite in your notes. You can draw this off to the side if you want, but you can also just listen through the explanation because this is where this formula is going to come from. So if I think about wanting to find this height h, the altitude of my triangle, I'll notice that I have an angle here of 52.3, and I have a hypotenuse, because it's across from the right angle, of 5. So I could say that the sine of 52.3 degrees is equal to the opposite, which is h, over the hypotenuse, which is 5. In which case, h is really equal to 5 times the sine of 52.3. Well, that's what I wanted to put in here for h. So if I really finish out this formula, I have 1/2 10.3 times 5 times the sine of 52.3. Well, looking at my original triangle, let me erase all my markings, the area of this triangle then was really equal to 1/2. That's just going to stay because the area formula for a triangle. Here's my base, this side here. Then I didn't need my height. I just have 5. That's this side here. And I have the sine of this 52.3 degrees. I don't even need my altitude officially. I could have just said this is 1/2 of a side, we'll call it A, a side, we'll call it B, and then this angle, well, if this is A and this is B, that means this would need to be C, so this would be the sine of angle C. So a way that we can find the area of a triangle if we don't know the height is to say that the area of the triangle is equal to 1/2 A times B times sine C. Now, it won't always be angle C that you're given, right? So we could rearrange this formula and say this is 1/2 B times C times the sine of A, or 1/2 A times C times the sine of B, or 1/2 X times Y times the sine of Z. What's important is that your A and your B are sandwiching around this angle C. Okay, so draw that little picture for yourself because that's what really needs to happen in order to use this formula. So find the area of the triangle using this given information. I've got this lovely picture drawn. So the area of a triangle starts with that 1/2. And then I need two sides and an angle sandwiched in between them, or included in between them. Well, here I have a side, B. Here I have another side, A. And then I have my angle that's included in between them. So I'm going to take the sine of that angle. Using my calculator, I can find that the area is equal to, let's see, we've got 1/2. I'm just going to use 1 divided by 2, right? You could also use 0.5. So 0.5 times 62 times 20 times the sine of 130. Again, make sure you're in degree mode. And I end up with an area of 474.95. And this would be units squared because I'm talking about area. So had this been, for instance, 20 feet and 20 feet, then I would say that this is square feet. All right, next one. Oh, that's my proof. Example 7, find the area of the triangle using the given information. Okay, setting up my area formula. Area is equal to 1/2 AB sine C, or really it's just a side, the angle included in between it with the other side, right? We've got to get that kind of picture set up for ourselves. Well, if I look here, I know this side is 29, That's all well and good. And I've got enough angles to pick from, but I need to do the work to find another side because I only have one of them. So maybe I want to sandwich 16, in which case I need to do some work to figure out what this side is. Or maybe I want to sandwich the 75, in which case I need to figure out what this side is. And I'm going to choose to do this one. I'm going to look for side B. I do not have a right triangle, in which case I can't use SOHCAHTOA, but I can use that law of sines that we just learned. So first thing I need to find is an angle and side opposite pair. So this angle A is going to be 89. Oh, so close to a right triangle, if only. So I'm going to set up that 29 over the sine of 89 degrees will be equal to, I said I wanted to find B over the sine of 16. Take a second in your calculator, figure out what side B is. I'm waiting for you. Great, I got 7.99. Hopefully you did too. So now when I go back to my area formula, I would say that the area is equal to 1/2. I've got 29. I've got 7.99. And now I just need that angle squished in between them. So that's going to be the sine of 75 degrees. All in your calculator, I'm going to round to 112. This one did have units, so inches squared is your area. Okay, so again, it doesn't matter which two sides and which angle is included in between. You don't have to keep track of A's, B's, and C's. It's just that you want to get this picture in your head that you've got to have a side and another side, and you've got to know the angle that's included in between them in order to use the formula. All right. This one goes back to a little review of the law of sines and some other good trig applications. So it says the angle of elevation to the top of a building is 21 degrees. At a point 80 feet closer, the angle of elevation to the top of the same building is 33 degrees. Approximate the height of the building. So what I am looking for is this height right here. What I know is that when I was walking towards this building, the angle of elevation, so looking out and then up, was 21 degrees. I know that when I moved 80 feet closer, so when I walked 80 feet closer to this moment here, now when I look up, I have an angle of 33 degrees. And that's all I got. So how in the world is this going to happen? If I need this height over here, well, that height is inside this big right triangle, right? We can assume that this building has been built perpendicular to the ground. So this red height is inside this really big triangle, but I don't know this distance here, so that's not going to help. This height is also inside of this smaller right triangle with the 33, but again, I don't know this distance or this distance. So I need to do some work to figure out some missing sides. Well, I just learned that I can use the law of sines to do that when I don't have a right triangle. So let's do some investigative work with geometry. If this was 33, and these are making a linear pair, that means they are supplementary, so this angle is 147. Within this blue triangle, I then could find that this angle up here is 12. Okay, so like, why is that helpful? Oh, I see, Ms. Schwartz. 12 is across from 80. So that's a ratio that I could set up. I could say that 80 over the sine of 12 might help me get some stuff because I know that law of sines can be useful in finding sides. So a side that it might help me to find would be this one right here. I'm going to call this M. So I could say that that's equal to M over the sine of, let's see, that was across from 21. Well, the reason I want to find M is because if I look, M then is the hypotenuse of this right triangle. And then I could use SOHCAHTOA because I get to the right triangle, and that's super helpful. So I'm going to use some cross multiplication. I'm going to find that M is equal to 137.89 feet. So now what I have, I'm going to take this out of the picture so it's a little bit easier to see. This is the height I wanted to find. I now know that this side is 137.89. And I know that this angle down here is 33. Well, what relates the opposite side with the hypotenuse? That's just regular old SOHCAHTOA. Sine of 33, I don't know why I just wrote 30, is equal to h over 137.89. So I get h by itself. I'm just going to multiply real quick by 137.89 on both sides. And I end up that h is equal to 75 feet. Okay, so that one uses the law of sines. It also uses SOHCAHTOA. Remember, the reason why we use SOHCAHTOA is because we have this right angle, so we have a right triangle. The reason we use law of sines is because we have an oblique triangle, or a triangle that does not include a right angle. Don't forget your area formula, 1/2 AB sine C. But remember, it's really just about a side, and an angle included in between them.